Welcome back to All This Math. This is Professor Parker, and we also have Assata here.
Hi.
There she is. She's here. She's back. All right. And today we're going to cover a word problem, and I wanted to teach this to Assata anyway because she's not as familiar with ratios and proportions. So I figured she might as well be in the video since she can learn something while she's at it. All right. So first off, I want for Assata to read the problem or read the word problem out loud. All right.
Wilma Rudolph ran 2 miles in 23 minutes. At this rate, how long would it take her to run 10 miles?
Okay. So, Assata, do you know who Wilma Rudolph was?
No.
So that's an actual person, and I was being intentional about using the name Wilma Rudolph in this particular problem, even though this is an example of a problem that one of the students that I tutor had for homework, or it's one of her practice problems, and it was like somebody's name in there, like Mary or Sally or somebody. So I said, like, let's change the name, and then we can create another teachable moment or teachable opportunity and talk about an actual person. So I decided to talk about Wilma Rudolph. So I mentioned Wilma Rudolph in here. And Wilma Rudolph was also a graduate of Tennessee State University. So that's why I decided to throw on my Tennessee State University sweatshirt. All right. And it's also an opportunity to talk to Assata about Wilma Rudolph and also a little bit about Tennessee State. Assata, where's Tennessee State located?
You mean like the actual state? Or
Well,
the capital?
the state and the city that it's located in. Where is that? What state is it in?
Tennessee?
Obviously, that's why it's called Tennessee State University. What city is it in?
Nashville.
And is Nashville the capital of Tennessee?
Yeah.
All right, so that's another, little piece of geography while we talking about a math lesson. Now, Wilma Rudolph was an Olympic track star. All right, what are you doing? Wilma Rudolph was an Olympic track star, right? She went to the Olympics, I believe, in 1956 and also in 1960. And at one point, she was the fastest woman in the world, according to her records. All right. I remember watching a made-for-TV movie about her when I was very young. I need to find that movie. And I'm sure there are books about her that have been written, biographies. She might have even written an autobiography. I'm not really sure. I don't know a lot about Wilma Rudolph. I just know a little bit about her, like the fact that she went to Tennessee State University, earned her degree from there, and then later became an educator after she graduated and after she ended her track career, I believe. And she was an Olympic runner. So this problem actually is motivation for me to go learn more about her, and also motivation for you to learn more about her if you don't already. All right. Of course, an African-American woman from Tennessee, born and raised in Tennessee. And then she attended Tennessee State University, which is a historically black college, which is located, as Assata said, in Nashville, Tennessee. Right?
Mm-hmm.
All right. So you read the problem. Now, this is what a ratio is. All right. I need you to pay attention. All right?
Mm-hmm.
All right? Because this is not just for them. This is also for you. All right, sis? So, a ratio. A ratio is, do you know what a ratio is?
No.
All right, ratio is basically a fraction. It's a fraction or it's a relationship between two numbers. All right, so here we have a ratio. If you ran 2 miles in 23 minutes, that's a ratio right there. Now, sometimes you'll see a ratio written like this. Like I could express this as 2 and then a colon and then 23. All right, so 2 miles, for every 2 miles, it takes 23 minutes. 2 miles, 23 minutes. Or you could write it as a fraction, 2 over 23. That's what we're going to do. We're going to write it as a fraction. So she ran 2 miles in 23 minutes. All right, 2 miles, 23 minutes. Now, this is important because with this information, then we can figure out the answer to this question. How long, and I'm going to put that in brackets, how long would it take her to run 10 miles? So 10 miles, right? So you know what she could do you know how long it takes her to run 2 miles. But now you want to figure out how long it takes her to run 10 miles. So you know there's a relationship between 2 and 10, right?
Mm-hmm.
Isn't 2 times 5 equal to 10?
Uh-huh.
So at this rate, right? Meaning at the same rate, she does just as much, right? She's able to run just as far in just as much time. So if she can run 2 miles in this much time, how long would it take her to run this long or go this far, right? And one thing to think about, if you think about it like mentally, it's kind of like, think about the relationship between 2 and 10. If 2 times 5 is 10, this is 5 times as many miles, or this length is 5 times longer than this, right? Because 2 times 5 is 10, right? So shouldn't it take her 5 times as long if it's the same rate? That's what it means when you see in a word problem it says at this rate, or at that rate, or at the same rate. That's what that means. All right. Now this is how you set up the proportion. A proportion is when you have a ratio equal to another ratio, and you write it down like that. That's what a proportion is. So the first ratio is 2 over 23. And then you put an equal sign. So that's the first ratio. That's 2 miles in 23 minutes. 2 miles, 23 minutes is equal to 10 miles over, we don't know. How many minutes? It says how long. So that means we don't know. That means that's something we have to figure out. So we use a variable to figure that out. So what variable do you want to use?
2 miles. So
What variable do you want to use?
doesn't matter.
It doesn't matter. Any letter you want.
A.
Okay. For your first name?
Yes.
Right. So 2 over 23 is equal to 10 over A. All right. This is how many miles on top? 2 miles, 10 miles. This is the length of time on the bottom, 23 minutes. We don't know how many minutes, but we can use algebra to figure it out, right? I like to call this next step the Malcolm X method. Some people call it the butterfly method. Some textbooks call it the cross product property. It's all good, whatever you want to call it. But I call it Malcolm X because I like to evoke the name of ancestors when I'm doing math. All right? Just like we evoke the name of the ancestor Wilma Rudolph while we're doing this word problem.
Ancestor.
So 2 times A
We don't know.
is 2A. 2 times A is 2A. So you write 2A.
So A is like a 1.
No, A is not like a 1. We don't know what A is. A could be any number. You don't know what it is. Don't say that. A lot of students make that mistake and say A is like a 1. It's not like a 1.
7.
There's one of them,
9.
but we don't know what A is equal to. Not yet. Now, 23 times 10 goes on the other side of the equal sign.
So we would have to do 23.
What does this equal? 23 times 10.
230.
Right. Because 23 times 1 is 23. And what's next?
You attach the 0.
You attach the 0. Right. So we got 2A is equal to 230. Looks like a 3, but it's not. I promise you. 230, right? I don't like how that looks. So 2A is equal to 230. Now, do you remember? I told you how to do this before. Do you remember how to solve for A?
No.
So in order to solve for A, that means we need to isolate A. You know what the word isolate means?
A little bit.
Isolate means to place something by itself with no other things around it. Isolated, right? It's by itself. All right. Right now, the two of us are in this room. If you were isolated in this room, that means I would leave. I would leave. You would be here by yourself. You would be isolated. Understand? So if I want to isolate A, I need to get rid of something, right? If I want to isolate A on the left side of the equal sign or the left side of the equation, what do I need to get rid of?
2.
I need to get rid of the 2. So I need to get rid of the 2. Now there's a specific way to get rid of the 2, which is I have to do the opposite operation from what the 2 and the A are doing with each other. 2A means 2 times A, right? Times means multiply, right? What's the opposite of multiplying?
Divider.
So in order to get rid of the 2, that means we got to divide by 2. So we're going to divide this by 2. And also because it's an equation, if I divide by 2 on the left side, do I have to divide by 2 on the right? Yes, because it's an equation. If I do something on the left, I also have to do it on the right.
But we don't know what A is. So.
That's not relevant right now. That's not relevant. I want you to focus on one thing at a time. Do I need to divide by 2 over here?
Yes.
Yes, because it's an equation. And if we divide by 2 on the left, we divide by 2 on the right. So now we divide this by 2. What's 2 divided by 2?
1.
So that becomes 1A. 1 times A, what's 1 times A? What's 1 times anything?
1A.
What's 1 times anything? It's that
Same
thing.
number.
So you don't need to say 1A, you just say A. So this is just A. All of this becomes just A. Just plain A. Now, this is an equal sign. So whatever number's over here is going to be what A is equal to. And then we will know what A is from doing this work. From doing this work, and this work. What's 230 divided by 2? Do you know? Without a calculator. Let's break it up. 200 plus 30.
Wouldn't that be a decimal?
What's half of 200? What's half of 200? What's half of 15? What's half of 30?
15.
15, right. I messed up. I gave you the answer. So if you're trying to find half of 230, or you're trying to do 230 divided by 2, you could just break 230 up into 230. Half of 200 is 100. Half of 30 is 15. So then you just put these numbers together. What's 100 plus 15?
115.
115.
115.
So it should take her, if it took Wilma Rudolph 23 minutes to run 2 miles, and then she ran 10 miles, how long would it take her to run 10 miles? We expect it's going to take her 115 minutes. Now, here's what I also want you to do. I want you to tell me what this is in hours. So, how many minutes are in 1 hour? How many minutes are in 1 hour?
60.
60. So 115 minutes is how many hours?
It's 1 hour.
1 hour and what? How many minutes left over? Because 120 minutes is 2 hours.
1 hour and 55 minutes.
Right. How'd you figure that out?
I know 1 hour is 60 minutes. So that is 6 times 2, which will give me 120. 5 away from that. So subtract the 5 from 60, get 55. Then that's 1 hour and 55 minutes.
That's pretty impressive. Or you could have did, well, there are multiple ways it could be done. You also could have said, well, if 60 minutes is 1 hour, you could do 115, take away 60, which would be 15 plus 40, which is 55. So you got the 1 hour for the first 60 minutes, and then the leftover is going to be 55 minutes. You know, but there are a lot of different ways we could do this. But this is the answer to the question. Using a proportion made up of ratios, because a fraction is a ratio, all right? So when two numbers have a relationship with each other, like this is how long she could run in this amount of time. Those two numbers have a relationship with each other. That's called a ratio. That's what a ratio is, right? So now you know what a ratio is. So when you hear somebody talking about ratios, you know what a ratio is. It's basically a fraction made up of two numbers that have a relationship with each other. Just like we have a relationship. I'm your father, you are my daughter, right? That is our familial relationship. These numbers have a relationship, all right? And then from this relationship, if two other numbers have the same relationship, so when you see, look, it says at this rate. That means that there are other numbers that have the same relationship with each other, right? So if she could run 2 miles in 23 minutes, then how long is it going to take her to run 10 miles? So you set up a proportion in order to be able to figure that out. Distance over time is equal to distance over time. I should have wrote that. So yeah, I should have wrote that first. Distance over time is equal to distance over time, right? And then from there, you take the words and replace the words with numbers. So really we should have started here. I neglected to input that or write that on the board. You write the words and then you replace the words with numbers. She's so silly. Replace the words with numbers, and then I do the Malcolm X method where I cross multiply and I put each product on one side of the equal sign. 2a equals 23 times 10, and then I simplify 2a equals 230, and then I'm trying to isolate a, so I get rid of the 2 by dividing 2 by 2. That leaves me with just a. And then whatever is on the other side of the equal sign is what a is equal to. So then by the time we're done, we do know what a is equal to. So it would take her almost 2 hours to run 10 miles. All right. And Wilma Rudolph was a sprinter. She was a sprinter. So I don't even know if she would be doing this. but maybe she would do it. She would have did it for conditioning or something. I don't know. But yeah. So did you learn something new today?
Mm-hmm.
All right. So now listen. Come here. So what we're gonna do is, now that she knows how to do this, now she can practice. Because if she don't practice, she's gonna forget, and it's gonna be like almost like as if, you know, I might as well not even taught it to her. So we're gonna go practice, and I highly recommend that you go practice as well. Use this video as a guide, like we're gonna do. She's gonna use the video as a guide, and you can use the video as a guide, and you can go practice problems with ratios and proportions. And if you're a parent watching this, your children are going to see this in school. Your children might have already seen this in school. If they didn't understand it, you let them use this video as a guide, right? And also, now that you understand it, hopefully, you can help them with their homework. You can help them study for their quizzes and their tests, and that's going to remove a lot of the stress that they have, and that's going to remove a lot of the stress that you have as well. All right? Now, we about to get out of here. Anything you want to say, Assata?
No.
All right, well, Assata, I appreciate you helping me do this video. And like I said, we about to go practice some of these problems. Well, she about to go practice some of these problems. All right? And we're going to catch up with y'all in the next video. All right? Peace out.